Okay, so we are going on, we're going on to section 3. Adding and subtracting polynomials is not meant to be belittling to you, it's just a review. And then multiplying polynomials should be pretty straightforward for you. Okay? Adding and subtracting polynomials, how else could you describe what we're going to do in this problem? Yeah, something like that.
Add the like terms.
Yeah. What word do we use besides add? Combine. Because sometimes it's addition, sometimes it's subtraction. But when you have plus or minus between two polynomials, you're combining like terms. How you do it's up to you. When it's addition, the parentheses around the polynomials really don't matter at all. You're just going to combine the y squares. What do you get? 3y squared. Then you have y's and y's. Negative 6y. And the numbers, the constants, positive 1, negative 4. That simple. Now, with that said, it's that simple. The plus sign, the parentheses don't matter. But the minus sign, it does. And some of you are going to be tempted over and over again, oh, I don't really need to show everything. I can do it in my head. If it's subtraction, I'm going to rewrite it. That way, I'm not going to screw up as often. Doesn't mean I won't still make mistakes, but I will make fewer of them. And what will typically happen is people will say, okay, 12x squared minus 11x squared, because these are like terms, does in fact give you the 1x squared. But after that, it's 8x minus x is 7x, and that's where you get the most commonly made mistake in algebra. Can't happen. Okay, you guys can't make that mistake any longer. Take less than 2 seconds to rewrite it, and then combine and get 9x instead of 7x. And negative 3 and negative 5, negative 8 instead of 2, which is what we get all the time for errors. Everybody follow that okay? Combining like terms easy. Give it a try. See how you do. All right, here we go. So if you rewrite again, then you can start your combining like terms. You don't need to be in descending order to combine like terms. When you do the combining, then you can just put your answer in descending order. So 8b to the 4th in the first spot. There's no other b squared, so minus 2b squared. There's no, whoops. There's no other b cubes either, so 6b cubed minus 2b squared. Wow, these are heavy duty. And then we got a plus b, and then these are like terms, minus 16. That look good? Okay. Okay, now we're going to get into some things that will help you with the only stuff that will be new today probably for you. So we're simplifying. Simplify means 2 things. Anytime you see the direction simplify, you do this first, you do this second. What's the first thing you do? But when you say simplify, it means 2 things. It means
small.
Don't overthink simplify. What are we going to do here? You're going to distribute. And you're going to get 10x to the fourth minus 2x cubed. Now, tell me what we did. And don't use that D word.
Multiply.
More obvious. It's so obvious you aren't even saying that's what happened. What happened from here to here? We did. We multiplied. We distributed. What did we accomplish?
Bigger? Took out any, you wrote it out. Hatchets.
What's here that's not here? More obvious. What's here? The parentheses. Step number one to simplify, when you see these directions, the first thing you do is get rid of parentheses. Did I miss it? Just didn't want to say it loud enough? Not helping. I know the answer, I'm not telling. After you get rid of parentheses, simplify 1, get rid of parentheses 2. Don't have to do it here.
Or like combine like terms.
Combine like terms, very good. We don't have to do it there because there's no like terms. But that's what the direction simplify means. Get rid of all your parentheses, combine all your like terms.
What it's an exponent outside of parentheses, that should be combined together. On the sides.
Because it's the product property. So you're multiplying this times this, so you add your exponent.
Oh, okay.
It's not like x cubed to the first type of thing. It's not power of a power. So where you would multiply exponents. This is the product. Good question. Now here's where things start to get messy. And you have two choices on how to handle this problem. So I'll show you both ways. You do whatever you want. The first way I call double distributing. So we're going to distribute the y first, like this. And you're going to get y to the third plus 6y squared minus 2y. And then you're going to distribute the negative 1. And you're going to get negative y squared minus 6y plus 2. And then you're going to combine like terms. You're going to get y cubed. You're going to have 6y squared minus y squared is 5y squared. Combine the y's and your constant. That's certainly one way to do this problem. That's double distributing, works great. Be meticulous. Don't race, don't try to skip steps. It's all good. The other way to do this problem is to take y squared plus 6y minus 2 and multiply it vertically, just like a 2-digit number times a 3-digit number. Like if you were doing 31 times 124, you would multiply like this, which is what we're going to do right here. Multiply, multiply, multiply. And you're going to get negative y squared minus 6y and plus 2. Then you would do the 3 times the 4 times the 2 times the 1, and you would line them up in like terms. This would be negative 2y plus u. This would be plus 6y squared. This would be a y cubed. Draw a line and add it down. Combining like terms, that's what you do. got. I don't care how you do it. Binomial times binomial, you FOIL it, your monkey method, whatever. Binomial times trinomial, it gets messy. Trinomial times trinomial, it's even messier. You have to just grind it out. Right? Now, you guys know a plus b times a minus b. When you multiply, you get difference of the squares. You know how to square a binomial. 9 words, square the first, twice the product, square the last, and you get these two results. Now we need to talk about cubing binomials. I'm sorry? There is a pyramid. It's called Pascal's triangle. I don't know how valuable it is for a cube. In other words, maybe it's worth it, maybe it's not. For a cube, I think it's probably a 50-50 on time. Sometimes it might be a little bit faster to use Pascal's triangle. Sometimes it might be faster to just do it this way. I'm just going to show you 2f plus 1 cubed. Rather than try to do this and memorize a pattern, which is going to be kind of daunting, change it to 2f plus 1 squared times 2f plus 1. Because everybody knows how to square the binomial, I hope. Again, the 9 words. Step 1, step 2, step 3. Square the first, twice the product, square the last. We haven't talked about those in 4 weeks. But when we take this binomial, 2f plus 1, and we square the first, we get 4f squared. Double the product is 4f. Square the last is 1. So we squared that binomial. Now we're going to multiply it by 2f plus 1. So it is going to take a little bit of an extra step over Pascal's triangle, but we'll deal with Pascal's triangle a little later. Now we're just going to double distribute, if you want, the 2f here, here, and here. 8f cubed plus 8f squared. Sorry. Yeah, this is still is 8. 8f cubed, 8f squared, 2f. And then we distribute the 1 plus 4f squared plus 4f plus 1. So when it's all said and done, plus 6f plus 1. So we're double distributing the 2f and the 1. The only thing I want to remind you of is that every term that you see in a polynomial owns the sign on their left. And although it doesn't matter on this because everything's positive, it's going to make a big difference when this is a minus. So keep that in mind. And then you have application of this stuff so that you have a prism and volume is length times width times height here. So the volume in terms of x would be x times x plus 6 times 2x plus 1. Sometimes you get choices in your world and in math and in everything. And sometimes you make a bad choice. Okay? And you pay a penalty for that. If you make a bad choice and you pay the penalty, you got to live with it. You made the choice, you have to deal with it. Especially if you know the consequences going in. If you didn't know the consequences, then it's not such a big deal. You know, oh, I screwed up, I got consequences, but I didn't really know it. You're not going to make the mistake again, hopefully. When you have something like this, what do you call this term right here? What do you call this one here? What is it? They're all, yeah, there's three factors. What do you call this factor? It has a name. Someone said it. Binomial. What's this one called? Monomial, and this is a binomial. You want to save the monomials till the end. Do not distribute this x times this. You can do it that way. You will still be able to get it correct, but you're more apt to make the error. It is much easier to multiply those binomials right there than it is to distribute and then multiply the two resulting binomials. And remember, when you multiply this x, you don't do it times everybody, it's just times one of the binomials. So FOIL, monkey method, whatever it is you do, and I'm going to multiply those. So we're going to get x, and then x times 2x is 2x squared. 6 times 1 is 6. 12x and 1x is 13x in the middle. It's way easier to now distribute that x than it is to multiply binomials that have different degrees. So 2x cubed plus 13x squared plus 6x. That's what the volume is, written as a polynomial in decentral order. And that's what we're looking for. Okay? So you can make it more difficult by distributing here and then multiplying the two binomials, but this is really the way to go. Everybody good on that? Okay? See if you can do the cone. Volume of the cone, I'm giving you the formula. All right, Julia, what are we going to start with for our volume? I guess we're doing this in terms of x, right? What'd you start with?
1/3 and then x minus 3 squared
Excellent.
times x plus 10.
Yeah. So that's your plug-in to the formula, and again, they gave us the formula, so you plugged it in. Okay. Taylor, were you able to square the x minus 3? What'd you get?
X squared minus 6x plus 9.
Fantastic. That should be the second thing you
X
do.
plus 3. X
Okay.
plus 3 on x.
I got it. Got it. Okay. The next thing you should do is double distribute the x plus 3 to the x squared plus 6x plus 9. Okay, hopefully. Zach, what'd you get when you did that?
Plus 3x plus 6x minus 18x plus 9x plus 27. So simplify it.
Hold on, let me catch up to you two. So, go ahead, x cubed.
X cubed minus 3x squared minus 9x plus 27.
So that should be the product of these two when you simplify. Get that up a little higher for you. Lexi, when you distributed the 1/3 and the pi, how'd you write your final line?
I didn't go that far.
Did you get this far?
Yeah.
Okay. The only thing you have to do now is you've got to distribute all the way through. You can't leave it as, this is technically a constant, even though it looks like that's a variable. We're going to push it through. So when you multiply here, what are you going to get?
1/3 pi x cubed.
X cubed. So I'm going to write it as pi over 3 x cubed. But what happens when we go here?
Negative pi over 3 3x squared.
So what will happen when you do pi over 3 times 3?
Oh, because
So what will we have?
pi
x squared. So minus pi x squared, because those 3's will cancel. And then what will happen when we go here?
It's negative 3x.
What else? So how am I going to write it? I'm not going to go negative x pi or 3x pi.
Negative pi 3x.
Does that sound right?
Negative 3 pi x.
Very good. Good save. Negative 3 pi x. And then the last spot will just be plus, how much?
9 pi.
9 pi. Good girl. So there's your volume in terms of x for that cone. Okay? It's not a hard problem. You're just multiplying 4 things together, really, although this is treated as 1. But it gets really ugly. If you can't do this, you've got to practice. If this is really easy for you, then there's only so much of that you can do. Again, you should know difference of the squares. You should know squaring binomials, PSTs now. Okay? Binomial squares. So that when we take and we're multiplying 2x minus y and 2x plus y, you don't have to FOIL all that out. You just square the 2x. What do we get there? 4x squared minus, and then square the second one. So you don't have to really spend a lot of time foiling. If you have a plus b times a minus b, your answer has to be a squared minus b squared. A minus b, a plus b, a just happens to be 2x. 2x all squared is 4x squared minus y squared. No need to make this really complicated. Some of you are still going to say, oh, I really don't want to learn those things. I'm just going to do this every time. You got to learn the shortcuts. What do we call this? Example 10 here. Oops. What do you call that? What is it? No, that's definitely not a perfect square trinomial. Like factored down, oh my God. Come on. Hey, you're overthinking again. What's this? What's that? What's it called? We're not very creative in the math world. We name them what they are. It's a binomial square. How do we square binomials? 9 words, 9 letters, whatever. Square the first. What do we get when we square the first? Twice the product. What do you get when you multiply? Not 35. Not negative 35x. And then double that. Negative 70x. Square the last. Plus 25. Last term's always a plus. Now that is called perfect square trinomial. When you square a binomial, you get a PST, a perfect square trinomial. Totally, dude. Okay, so this is a floor plan of some sort, and they want you to tell me what the area is of this floor. So we want A in terms of X for this floor. Look, in order to find the area, total area of this figure, you're going to do rectangle plus little rectangle, big rectangle, little rectangle, plus triangle, plus triangle. Or you could do the area of a trapezoid if you know that. But the people who are sitting here not doing anything definitely don't know that. All right? You could have. But again, Aren't you still doing this? So all of these are fantastic ideas. In fact, these two triangles are the same. So you could have just done the big rectangle, the little rectangle, and two triangles, right? Because those triangles have the same dimensions. Or you could have treated it as, well, those two triangles together make a square. That works fine too. So 2x plus 1 times, how long is this side right here?
X plus X plus X.
4x minus 2. So from here to here is x plus 2x minus 2 is 4x minus 2. And then the little rectangle is going to be x times 2x minus 2. And the triangles are 1/2 x times x, or x squared. Some are easier than others to simplify the concept, really easy. X squared. This one's pretty easy. 2x squared minus 2x. And then you got to do the monkey method or whatever it is you do. You're going to get 8x squared. You're going to have a minus 2. 4x and a minus 4x cancels. Is that right? Even better. So now all you have to do is combine like terms. A of x.
That left. No, say X first.
Just this.
Oh, I see.
Are we good?
Yes.
Okay, so 8x squared, 2x squared, and 1x squared, 11x squared. Minus 2x, minus 2. That's your area. That's the formula for area of a trapezoid, which is what ultimately this entire shape is. Your two bases, 4x minus 2 and 2x minus 2. And your height, 2x plus 1 plus x, or 3x plus 1. So you could have used that.
No, no, that's a pentagon. No, hexagon. That's the sides. So it can't be a trapezoid, right?
You do the trapezoid.
So this, oh, you're talking about this trapezoid, Rachel? Just right here?
Yeah.
So this would be the 4x minus 2, and this would be the 2x minus 2. So you'd still have to do the big rectangle plus that?
Yeah.
Yeah, that's fine too. This trapezoid formula here, how do you know which way to do it? It doesn't, but how do you know which way to do it? Whichever way jumps out at you. Which means you may make a bad choice. But here's what's worse. You have all these choices on what to do, and you say, should I do this table, or this table, or this one, or this? This is worse. Sitting here not making a choice is worse than picking the worst choice. You have to try something. Commit to something. It's just that easy. Okay? This is your assignment. However, we have something else we're going to be doing before. We have a formative quiz that we're going to give you today so you can see where you are. So right now, close your books, close your notebooks.